Hi all, welcome to the video. In this video, we'll be discussing on a research paper on big data analytics. The contents which we'll be looking in this video are title introduction, problem statement, objectives of CX tuning, overview of CX tuning, working mechanism, multi-instance mechanism, reinforcement, learning, correlation expert knowledge model and tuning acceleration in CX tuning, comparison with existing methods and experimental results, and the conclusion. The paper which we will be discussing in this video is Correlation Expert Tuning System for Performance Acceleration, and these are the authors of the paper. It was published on September 2nd, 2022. Let's look into the problem statement. The database performance tuning is usually complex due to numerous configuration knobs in the modern database like MySQL and PostgreSQL, which will be having over 200 knobs. Therefore, its complexity make it difficult for the users and the database administrator to find optimal configuration for specific workloads. Current auto-tuning methods often rely on exhaustive offline training and trial and error approaches, which leads to insufficiency of the data. Many systems offer only coarse-grained tuning, overlooking the diverse nature of workloads and the varying importance of knobs, which results in the suboptimal performance. The most time-consuming part of the process is the performance measurement needed to obtain the reward values, creating a zero-knowledge scenario. Therefore, integrating expert knowledge and correlation rules is essential to improve or enhance the tuning process, reducing the training costs and also improve the overall efficiency of the database optimization. Let's look into the objective of CX tuning. Introduce a correlation expert tuning system. CX tuning is a system designed to integrate expert knowledge into the database auto-tuning process, which identify and utilize relationships between various configuration knobs to make more informed tuning decisions. We'll be looking into expert knowledge model, external expert rules, internal expert rules, correlation rules. The first one, that is the expert knowledge module. The system includes both the external as well as the internal rules. Internal expert rules. External expert rules. It uses a multi-instance mechanism to classify workloads and also recommend optimized knobs for specific scenarios. Internal rules, internal expert rules, which capture learned correlation between knobs to better understand how configurations interact. Correlation rules. These rules help to filter out ineffective knobs combinations, focusing on those that are likely to improve performance based on past data and experts' insights. Utilize reinforcement learning for efficient auto-tuning. Under that, they are reinforcement learning framework, dynamic adaptation, and reduction of trial and error. The reinforcement learning model adapt tuning strategies over time, which help in optimizing the knob selection to match the workload needs as well as the performance goals. Dynamic adaptation. In dynamic adaptation, the CX tuning adjusts the recommendation in response to changing the workloads, which ensures ongoing database optimization. Reduction of trial and error method. In the reinforcement learning, it will be minimizing the unnecessary performance evaluation by learning from the past experience. Therefore, it reduces the inefficiency of the data. Reduce training time and improve performance. Under this, there are efficiency, faster convergence, enhanced performance. By incorporating expert knowledge, CX tuning skips ineffective knobs evaluation, speeding up the tuning. Faster convergence, expert rules help the RL algorithm finding optimal configurations quickly. Enhanced performance, the system aims for improved throughput, lower latency, and better resource utilization. Let's look into the overview of CX tuning. We have already learned about the external expert rules module, internal expert rules module, and internal expert rules modules. Let's look in the purpose of each. The purpose of external expert rules module, it classifies the workloads and recommends high performance configuration knobs based on the expert knowledge. Multi-instant mechanism, it categorizes the workload to identify relevant knobs for specific scenarios. Recommendation system, in this it provides optimized configuration to enhance the tuning. Internal expert rules purpose, it integrates learned expert knowledge and analyze the correlation between knobs. Correlation rule model, it captures relationship between the knobs to reduce the tuning search space. And knob constraint rule guides tuning with system resource limits. Working mechanism of CX tuning. CX tuning's working mechanism involves a symmetric iterative process to optimize database performance through expert knowledge and reinforcement learning. Under that, we'll look into classify workloads, recommend optimal knobs, train using internal expert rules. Under classify workloads, it uses the external expert rules module to classify the workloads based on their characteristics, employing a specific multi-instant mechanism. The purpose of classify workloads tailors tuning to each workload type for better performance, which increases the performance. It utilizes expert knowledge to inform tuning recommendations. Recommend optimal knobs. Recommends high performance configuration knobs based on workload classification. Focuses on relevant knobs likely to improve the performance, filtering out less effective options. Training using internal expert rules. The auto-tuning module trains the RL algorithm using insights from the internal expert rules module, provides correlation rules and constraints to guide training, speeding up the tuning process by avoiding the ineffective knob combinations. The system refines the tuning strategies in an iterative feedback loop, continuously improving and adapting to changing workloads. Multi-instant mechanism in CX tuning. Fine-grained workload classification. Multi-instant mechanism classifies the workload with detailed precision, considering the factors like read or write ratios and transaction types, which allows for tailored tuning to meet the specific needs for each workload. Dynamic high performance knob recommendation. Multi-instant mechanism dynamically adjusts the configuration knobs recommendation based on the real-time workload changes, which will be mainly focusing on the high performance knob to maintain optimal performance. Reinforcement learning RL in the CX tuning. It is a core algorithm. Reinforcement learning is the major important or the foundational algorithm which helps in balancing exploration and exploitation. Learning from feedback has already discussed reinforcement learning performance feedback to optimize knob selection over the time. continuously refining the recommendation for higher throughput and lower latency. It adapts to changing workloads, ensuring the effective tuning. Correlation expert knowledge model and the tuning acceleration in CX tuning. Correlation expert knowledge model in CX tuning. Under that, the first one is it identifies the knob relationship, and the second is it reduces the search space. Under identifying the knob relationship, it usually analyzes the interdependency among the configuration knobs, which allow for guided tuning that accounts for how knobs influence each other. It also ensures holistic tuning to avoid suboptimal configurations. Reduce search space. It recognizes knob correlation, narrowing down the tuning option to focus on promising configuration, which also enhance tuning efficiency by speeding up the process and reducing the computational overhead. Next one is the tuning acceleration in CX tuning. It skips unnecessary measurements. It uses correlation rules to skip irrelevant knob combination, which will save the time and the resources. Prioritize configuration likely to positively impact the performance. Informed decision making incorporates expert knowledge to make reliable knob adjustment, adapts tuning strategies based on past performance data and best practices. Now let's compare between the existing methods and the experiment results. Comparing with the existing methods, CX tuning addresses the limitations of existing auto-tuning methods like under best configuration, time-consuming searches, and heavy reliance on historical data. Auto-tune depend on high-quality samples which may be scarce. CDBT tune, which suffers from long training times and cost trained tuning. CX tuning advantages. So now let's look into the advantages of the CX tuning. It reduces the training time by skipping unnecessary evaluation, provides a fine-grained dynamic tuning through expert knowledge, and then it adapts to changing workloads for better performance optimization. According to the experimental results, training time reduction. CX tuning reduced training time by 67.77% to 77.67% when compared to CDB tune. Performance gains, which was achieved by 61.73% throughput improvement and to around 63.45 latency reduction across various workloads. The conclusion of the paper. CX tuning represents a significant advancement in the field of database auto-tuning by effectively reducing training time while enhancing overall performance. The system usually will be successfully combine reinforcement learning with expert knowledge, allowing for optimal tuning of database configuration. This integration will not only streamline the tuning process, which will also ensure that the recommendations are tailored to specific workloads, leading to the improved efficiency and performance outcomes. The experimental results demonstrate that CX tuning outperforms existing methods, making it a valuable tool for database administrators seeking to optimize their system. This was about the research paper on big data. Hope you all liked the video. Thank you.